Hello, hello, folks. All right, excuse me, kitty. I have to move you. You can't be here. Sorry. Move. Thank you. All right. All right. I'm gonna go ahead and start my recording here in Zoom. Good morning, folks. My name is Mr. Blake. I am here today to get you guys started with lesson 3 of 3. Let me just verify my audio devices are correct. Headset, correct. Yep. All right, we're good to go. So, this is lesson 3 of 3. In lesson 1, what we went over was what is a circuit? So just briefly again, a circuit is a pathway through which electricity can flow, okay? And that kind of just looks like this, just any kind of pathway, right? Like that. Now, voltage, okay, is the difference in electric charge between 2 points. So that was lesson number 2, okay? We talk about voltage, electricity flowing, just like how water flows, right? So say I have these 2 points where I have some electricity and none, okay? Just like water. We can connect a pipe between those 2 points. And then what do we have? We have electricity flows through that pipe. We're talking about voltage. How long does it flow? Okay. What's going to stop it from flowing? Well, what's going to happen is you get some of it comes over from here, and now you have some here and a little bit over there, right? And then it's going to keep going like that. And you think all of that's just going to go over there until we have this 0 over there? Well, then it's going to want to flow back, isn't it? So that's not what's going to happen. What do you think is going to happen? We have 8 on the left, and it's going to flow until, well, it's the same, right? And then it's going to stop. So that's our voltage lesson from lesson 2, okay? Our overview there. And then we talked about what is a battery. So a battery is you've got both of those spaces together in one, and there's a big wall, right? Nothing goes through the wall ever. And in this, we have our 2 spaces where one has a bunch of electricity and one has none, right? So our circuit that we make with a battery just looks like this. We connect this like that with a pipe, and the electricity flows through that, right? So that's our concept for lesson 2, voltage, okay? Now, I'm going to go ahead and split this battery apart into the 2 pieces again, just so you sort of see. We have, right, this over here, and then this over here. Okay, in here we have our electricity. Here we have none. Now, you can see that the pipe that I joined it together with, now, say I have that, I'm going to do another one exactly the same way. Okay, well, kind of. All right, and 8. This is way larger than that other one. Excuse me. It's the perspective I have looking like this. So we want 0 in here. But now this one, say instead of a pipe like this, what if I do a pipe like this? Really, really tiny. Okay. Now looking at these 2 things, which of them is going to have the electricity even out sooner? What do you think? The one with the bigger pipe or the one with the smaller pipe? So you guys have probably said that this bigger pipe is going to empty out, well, not empty out, but even out first. And the smaller one, where less is flowing at once, it's going to take longer to do that, right? You guys see that? So we can even make, more pipes, okay? We don't even have to talk about the size of one pipe. We can have multiple pipes, okay? Like this even. And then we got, all this flowing through here. Whereas this just has the tiny one, okay? So today, our main concept, current, is how much electricity is flowing at one time, whether we're talking about the size of individual pipes or if we're talking about there being many, many pipes all at once. The more pipes you have, the bigger the pipes are, the more electricity is flowing. And yes, a thing that has all this electricity flowing through it is going to even out sooner than a tiny pipe thing like this. Now, as it turns out, we've already done our project with the LEDs, and an LED, in fact, has a very small amount of current that it draws. So that means it has a very tiny pipe. So an LED is going to last a long time when you plug it in and nothing else with it. All right, we're going to switch over to our project cam now, and we're going to work with these concepts and series in parallel, okay? We're going to talk about what that is as we attach all these LEDs together. So I'm going to go over to my desk here. I'm going to move my keyboard and my phone out of the way. And then I'm going to cut over to the other camera I have prepared here. Okay, so this is over my desk here. Hello. And let me move my water bottle just out of the way here. Got it. So, series versus parallel, right? If we have, let me move my bin here just a moment. A bunch of lights, right? Here's our bunch of lights. Let's open these up. Remember, an LED, a light emitting diode. The word diode we went over in our first lesson. What is that? A diode is a one-way gate through which electricity flows. So it's only going to flow the one direction through the diode. It's not going to go the other direction. Now, flowing water, if you turn a water wheel, if you switch the direction of the water wheel just turns the other way. And a water wheel, like a motor, can work whichever way electricity goes through it. This is not true for a diode, which necessarily only allows electricity to flow one direction through it and not the other. So we see that this diode has two legs, and the longer leg is going to be the leg that touches the plus side of the battery. Okay, it's pretty easy to remember. Longer leg, plus side, there it is. Shorter leg, minus side. Okay, there it is. Now, all of our projects so far have included just a single light, okay? We're going to go ahead and make things a little bit more interesting now and work with more things. So, when I have the electricity go through this light from there to there, what do you think happens to it? Just like when you have water pushing a water wheel, after the water goes through the wheel and has pushed it, do you think the water coming out the other side is as strong as the water going in? No, it gets weaker, right? Because some of that force goes to turning the wheel in the water there. Now, the same is sort of true for electricity. When you have the electricity go through another thing, it gets weaker. So the question is, how many of these do you think we can put in a row and see that will work? okay? Let's see how many we can do, okay? We're going to build just a few little circuits here, okay? So what we're going to do is, sorry, I had to turn around. My cat's being mischievous. So we're going to make one that has 1. Well, we know 1 works. We don't need to make 1. We're going to make one with 2, 3, and 4. Does that sound good? All right, let's try that. So this one right here, instead of drawing it all out, I'm just going to go ahead. Well, I'll draw it out first. So we have tape that goes here to here and then here to there. Okay, our plus side over here, our minus side over here. And then the other one, sort of the same, only instead of 2 gaps, right, it has 3. And our minus side over here, like this. So we're going to get our tape. Hello, tape. Remember, you guys, this tape is really delicate, and it's really easy to kind of mess it up. So we want to be a bit careful, okay, as we go and do this. Let's get our second light, okay, prepared. Again, we got to make sure that the long leg points towards the plus. That's going to be this direction, okay, and then the short leg toward the minus. All right, so we're going to take this little piece of copper tape. Whoa, there we go. And we are going to connect here. For those of you watching live on Facebook, there is a 20-second delay, so I can't really see and reply to your comments very easily. But if you'd like to join us on Zoom, we're doing this lesson again tomorrow, and the link to that is in the post here and in my other posts, so you can find that. All right, so we got one more there, right? And then one more over here, okay? Those are our circuits. Now, let's go ahead and get circuit number 1 with 2 lights completed, okay? So we got that side there, okay? And then we got this side over here. Now, how are we going to attach our batteries, huh? I've got an idea about that. Let me show you guys. Oh my goodness, it's so difficult to peel these little tapes sometimes. Okay, there we go. And gonna get that side down. So we have a circuit with 2 here. Now, our battery, we're gonna go ahead and open a new one here. And we're going to push that out here. Now we look at our battery and we see on it is written that the plus side is this surface right here. I see a plus sign right there. I flip it over, that's the minus sign. Okay, so my plus side is just going to go down here, right? Okay, what I think I'm going to do is just, I want to be able to fold this over and complete the circuit. So clearly, my plus side, I can do that quite easily. That just goes straight up like there, right? So that's all I need to do to contact the plus side of the battery. So let me go ahead and peel away. Doggos in my neighborhood are excited about something. They're all barking. They just started a moment ago. All right. Let's make sure that this goes down. And again, we got to make sure there's a continuous pathway so we overlap the tape. Okay, it's very important that at that corner point we overlap the tape. We go all the way up to here. That's the plus side, right? Here, plus side. That's the plus side of the battery. And then to get it to go there, what am I going to do? Well, the tape is going to do like this, I guess. And then it'll touch there. And then from there we go like that. Okay. All right, let's get this one. So the way we have connected our two blue LEDs there is they are one after the other, right? We want to see if after it goes through the first one, if it's strong enough to then also light the second one. That's our question, okay? That we're trying to figure out the answer to. That's going to go there. Now when I touch that, sure, that'll touch there quite easily. All right, so we're good there. We just got to come down there and we're good to go with this one. So we rip off just a small amount and then we go ahead and come on. Again, so difficult, and it curls easily, so it's kind of requires some delicacy. There we go. All right, there to there. All right, you guys. So my LEDs are the right way. The plus side leg is this way. The minus side leg is this way. That's the plus side of the battery underneath there. And then on top is the minus side of the battery. Let's go ahead and see if 3 point, I think it was 7 volts will light too. Is that lighting too? Is not lighting too. Now, why would that be, huh? Let's take a single one. Make sure a single one lights. Oh yeah, look at that. Easily, huh? And this is a sound pathway. We can totally light one, right? So, even 2. We don't even have to go to 3. 3 is too many. 2 is too many. All right, guys. So how can we redesign this circuit with 2 to make sure that we get both of them to go on? This is the question we're considering as we come to the new concept here of series versus parallel. So these 2 lights are in series. They are one after the other. Now, if we make a new circuit with 2 new lights, we want to get both of those to go on. You see, we have a single pathway that goes through one and then the second light, one after the other. So those are in series. What we're going to do is arrange these 2 lights in parallel. So now what our circuit is going to look like is we get our plus side, right? And we come down from the plus side. And then what we do is we make 2 separate pathways, okay? Then we go like this. Those 2 pathways themselves come together and they go off to the negative side, okay? What I really should have done is mirrored that the other way because I'm going to use this corner, right? So not like this and not like this, but like this. Excuse me. Because my plus is going to be over here. And then my minus is going to be over here. Okay, so what you see is instead of going through one light and then the other, what we're going to do here is we're going to go through both lights at the same time. Remember, our plus side leg, the longer one, okay, needs to be pointed towards the plus side of our battery. So like this here, we're going to get the first one down just to sort of secure it in place. So we take our tape here. Come on. There we go. And we get the plus side of our first light down. Okay. I'm just going to get another one here to go to the other side. So our minus side of our light number 1 is going to connect to this other segment of tape that I'm peeling up right now. Let me go ahead and put that down. Okay. Beautiful. All right. I'll do the other light the same way. So the longer leg, the plus leg, goes over there, and then the minus side the other way. So our plus side here, we're going to go ahead and peel that away. Come on. Oh, it's so difficult. There we go. I got it. All right. So plus side leg for light number 2 is down. What's this? All right, there we go. And then the minus side leg, we're going to go ahead and take this piece of tape here and peel it. There we go. So the minus side leg of light number 2 goes down. Okay, there we are. And then my plus side, okay, same battery over here. Get that tape down. Put it just about right there. Right. Okay. Whoops. I think that's too far. I need more space on the edge. All right. So that's there. You know what? I'm going to give it even more space because I don't even really need that much. So I'm scratching that off. There we go. So that goes there. And then this is going to bend over like that. All right. So the same way, like this. All right. So very soon here, you'll have a parallel circuit and a series circuit. Oh no. Guys, this piece of tape is so long it's curling everywhere. There we go. Got it. All right. So this to there, like that. Now when I fold the tape, or that way, see? All right. So from there to there is our last little segment to do. So that is about this long. And that last piece to peel. Come on. Almost there, you guys. Ah, no. There we go. Did I get it? I think I did. Yeah. Great. All right. So our last piece goes right here. All right, let's see if our parallel circuit works. Look at that, you guys. The same battery is able to light 2 LEDs there. But when I use it here in series, those don't light. Okay. So this is our parallel circuit. And in a parallel circuit, the electricity, it flows the same strength through both of those at the same time. Okay. The reason why this one in series doesn't work is because when the electricity goes out here, flows through there, by the time it gets here, it's too weak to then go through this one also. So there we go. That's our lesson for today, you guys. You can use multiple devices in parallel. And in this case, right, the difference, the voltage, the strength isn't different than this one. It still has the same voltage. But what is different is instead of one single tiny pipe, this is 2 tiny pipes, right? So what we have here is through this current or through this circuit, more current is flowing than say just one pipe with just one of these, right? So what we can do is if we want to do an experiment, maybe we can get our measuring device, our multimeter, we can measure the voltage of a given battery. We can have it in our circuit, maybe hold that down overnight, right? And then see what the voltage is, how much it's been reduced by. You can maybe also have a second one with just a single light and then go ahead and see what the reduction is on that one as well. So those are some fun projects to do with lights and copper tape and understanding about how parallel versus series circuits work. All right, well, thank you very much for attending my circuitry class. This is lesson 3 of 3, so that's the end. And perhaps I'll go ahead and develop some more. And you guys may see those coming soon. But want to go ahead and thank everyone for tuning in today. And have a nice day, guys. Bye-bye.